what we're going to do is we're going to solve this equation. The first step for solving an equation of any type of equation is to distribute if you can. So you want to distribute first. Is there anything to distribute on this one?
Yeah.
The negative sign.
Yeah, the negative sign needs to get distributed. Negative times the 5 is...
Negative 5.
Negative times the negative 2k is positive 2k equals...
3 plus 3. Just
bring everything down. 3 plus 3k. The second thing is to get the variables together. All right, now there's two ways that you can do this. If the variables are on the same side, you can simply combine the like terms. If they're on opposite sides, like in this case, what we can do is add or subtract them. And so that's what I need to do. To add or subtract them, what should I get rid of? The 2 or the 3? All right, subtracting the 2k is a perfectly logical step because that'll get me the k's positive on this side, which is always a nice thing, and then bring everything else down. Negative 5 equals 3 plus k. Yeah. Do what? Get the variables together. The next step, after we get the variables together, is to get the numbers together, right? So get the numbers together. Again, you can do this in one of two ways. You can add or subtract them to either sides if they're on opposite sides, or you can combine them if they're on the same side. How do I get the numbers together on this one? Subtract the 3 from both sides, and this will get me k is equal to negative 8. Now this problem is done. The reason why this problem is done right now is because there was no dividing that was necessary. The last step for solving an equation is usually to divide, which I do not need to do in this case because there's a 1 in front of the k. I don't need to do anything to get rid of it. Are there any questions about how to do that?
How should you do that?
There are two special cases that could come out of an equation like this. It's not common, but it does happen. The first special case is if you are solving and you get a number is equal to itself. So if you solve it, you subtract the 3k from both sides or something, and suddenly all your k's are gone, and you get 2 equals 2. This is an example of what is called infinite solutions. The other case is where you get a number is equal to a different number, like 2 is equal to 4. This is not true. Same thing happens. You subtract like 2k from both sides, and all your k's cancel out, leaving you no k's left, and 2 is equal to 4 or something like that. This would be an example of no solutions. This happens sometimes, but not very often. Are there any questions about the special cases? Okay. Number 2. Number 2 is exactly like number 1, with one exception. What's the only difference about this?
You got a graph?
Okay, there's graphing, but...
Oh, it has a greater than.
Yeah, it's got a greater than sign. Something that you should write down in the notes are what the signs are, because people ask me all the time. This symbol, the first one, is a...
Less than.
A greater than, so you should definitely write it down. And this one is a less than. All right? There's another couple things that you need to do, that you need to know about this. The next thing is about the type of dots that you would have. What symbol would give you a open dot? One of those guys without the line underneath it. And what would it look like for a closed dot? With the equal to line. So this would be a closed dot on it. The next thing that you will need to know is you will need to know about the direction of the arrow. A greater than symbol would go which direction?
Shade to the right.
To the right. And a less than symbol would shade to the... And that is, of course, included whenever we do the greater than or equal to and less than or equal to as well. There is one important rule, and I put it under the special case column because it does happen only every once in a while, and that is if you divide by a negative, you have to flip the sign. Make sure that you know that. If you divide by a negative, you have to flip the sign. It's an important rule. It happens all the time. Well, about half of the time it happens. So we're going to go ahead and solve this. I'm going to use the same steps as we did in number 1 because the solving is not any different. However, I do need to pay attention to the inequality sign. If I ever divide by a negative, I have to flip it around. First step, like above, says to distribute. So if I distribute, negative 4 times 5 is what? Negative 20 plus 20n plus 7n. The next step says to get your variables together. In order to get the variables together, do I have to add or subtract from both sides?
Nope.
No, I just combine like terms. 115 is greater than negative 20 plus 20n plus 7n is 27n. The next step, step 3, is to get your numbers together. So how would I get the numbers together on this one? Add 20 to both sides. That'll get me 135 is equal to 27n. Not equal to, but is greater than 27n. And then the last step is to divide. Right? That'll get me 5 is greater than n. Did I have to flip the sign? No, because I divided by a positive. So I don't have to flip the sign in this case. However, about half the time you will. Now, it is important that you want to flip this around. Flip this around. Why is that important?
When you graph it, you go that way.
Right. If I don't flip this around, a lot of people would look at the greater than symbol and would say graph it to the right because it's greater than.
Yeah, that's true.
But this is a 5 is greater than n, which means that n is less than 5, right? If 5 is bigger than n, then n must be bigger than 5, or less than 5. So if I graph this, I'll get it right. I don't want to graph that because that'll usually tell me I'm going in the wrong direction that I should be. So I'm going to put an open or a closed dot at 5.
Open.
And open, would I go left or right?
Left.
Left. And this would be how to solve an inequality. Are there any questions on how to solve and graph an inequality? Okay. This is going away in a few seconds. If there are no other questions, I'm going to make it go away.
1, 2, 3, go.
1, 2, 3, go.
Problems from the world.
All right, so if we scroll down to number 3, this is graphing a line that is in slope-intercept form. If it's in slope-intercept form, what I need to do is find the b, so find b. And then the second thing I need to do is find m. Remember that these equations are y is equal to mx plus b, where m is in front of the x and b is the number sticking out there at the end. What is b in this case? What does b mean? B is your y-intercept, and m is your slope. Slope is written as rise over run. Another important thing about m is what type of slope is this, positive or negative? It has a positive slope, and this is a negative slope. Those are important things to know, because if you don't know the direction that your slope is going, if it's right or not, you can tell by looking at the positive 3/4, knowing that it should be going up and to the left as we go, or up and to the right, rather. So what we want to do is we want to first start at b. What is b in this case? -1 is b. That's my y-intercept, so I'm going to put that on the y-axis. What is the slope? 3/4, which is your m. That will send me up 3 and over 4. And this is where that point will go. Of course, we could also go down 3 and to the right or to the left 4. That would be another point that could be on this line.
Are there no special cases?
I'll get to that in just a second.
Oh, okay.
This is the graph of the line. Now, as far as special cases go, the thing that everybody always asks me when graphing a linear equation is what happens if it's x equals something, x equals a number. What type of line is that?
Up and down.
That line goes up and down. What about y equals a number? it goes left to right. So these are the special cases of the linear equations. If the equation just says x equals 2, it's going to go up and down through positive 2. If it says y equals 2, it's going to go from left to right through positive 2. Are there any questions about those two special cases?
No.
Okay. So then let's go on to the next one. Number 4. What is the only difference between number 4 and number 3?
You gotta get the y by itself.
Yep, get y by itself. In order to do that, I need to do a couple steps. The first thing I need to do to get y by itself is to add or subtract x, the x term. The second thing that I need to do is divide by whatever is in front of the y. That usually will get y by itself, usually. So what I want to do now is minus 3x. That's what was stated, so we're going to do that. Can I combine those? Negative 2y is equal to what? Negative 3x minus 6. The second step was to divide. What am I going to divide by in this case? Divide by a negative 2. Make sure to divide everything by a negative 2. Those will cancel, leaving you y is equal to, what is negative 3 divided by negative 2? Positive 3 halves, very good. 3 halves x. 6 divided by 2 is positive 3. Now everything else is exactly the same as was before. So on my second step after I have solved for y, gotten y by itself, I want to just graph it, like above. So I'm going to look for my slope and my y-intercept. Where's my y-intercept? So 3 is my b. I'm going to start at 3. My slope is positive 3 halves. It means it's going to go up in that direction. 1, 2, 3 over 1, 2. I could have also gone down 3 and to the left 2, down 3 and to the left 2, down 3 and to the left 2, and these would be all my points. We'll then graph that in, and here's the graph of the equation 3x minus 2y equals negative 6. The special cases are identical to the special cases above it. There's nothing different about it. So like above, for the special case, if you want to write that down, you can. Or you could just write it down again. X equals number goes up and down. Y equals number goes left and right. So whatever you want to do, whatever you want to write there to indicate that those are the same type as the special cases. Are there any questions on how to graph a line not in slope-intercept form? Okay. So we're going to go ahead and go on to number 5. It says to solve the system of equations by graphing. Now, a system of equations is whenever you're having two lines that are going to cross somewhere. We want to know where they're going to be at the same spot at the same time. So the first thing we want to do is graph both. The second thing we want to do is tell where they cross. In order to do that, we need to list the point in an XY format. This is what the answer is going to look like. So we graph both lines, and then we tell where they cross. There are two special cases. The first one being that the lines look like this, parallel lines. What would you say if your lines were parallel?
No solution.
This is no solution, because they do not cross. The other special case is when you graph one line, and then you graph the other line, and you realize that they are exactly on top of each other. Exactly. This one is called infinite solutions. And you can usually tell that because the equations are exactly the same. Are there any questions about the difference between the two cases? Okay. So the first one I'm going to graph. Where is the b for the first line? Positive 2 is b. What about the m for the first line? Is 2/3. Very good. Up 2 over 3. It is positive. I could also go down 2 and back 3. This is the graph of the first line. What about the graph of the second line? Where is B for the second line? -4 is your B, so that's where you start. 8/3 is your M, so you count up 8 over 3. And that'll put you on this same dot over here, and you can see clearly that that's where they're going to be crossing. Can somebody tell me what the position of that point is? This is +3, +4. This is the actual answer. The graph is good, but the actual answer is where they cross. Are there any questions about that? Okay. Make sure you do not get those numbers backwards. 3, 4 is over 3 on the x-axis and up 4 on the y-axis. It's not the same as the slope. Do not write 4, 3. How's this one different? You got to solve it first. Step 1 is solve both for y. Step 2 is graph both. And step 3 is tell where they cross. So most of these are exactly like the previous one. Whenever you are going to do this, you will have the same two special cases of parallel lines as infinite solutions. Or sorry, no solutions, I apologize. Or lines that are directly on top of each other are going to be infinite solutions. So when I go to graph this, what should I do first? Or solve it?
What does it say? Tell where they
Cross. Yeah. First equation, what should I do to solve it? -5x from both sides. This will get me -4y is equal to -5x minus 12. Now what? Divide by -4. And y is equal to a positive 5/4 x positive 3. That is the solving of the first equation. The slope and the y-intercept of that, y-intercept is at positive 3. Now, can I go up 5 over 4? No, I can't. It is a positive sloping line, but I'm going to have to go down 1, 2, 3, 4, 5, which will send me to the left 4. Is this still going in a positive direction? Yeah, it is. So that is the positive 5/4 slope. We've got to do the same thing for the second equation. Subtract x from both sides. 4y is equal to -x minus 12. How do I get rid of the 4? Yeah, divide it all by 4. What is a -x divided by 4? -1/4 x. -12 divided by 4? Minus 3. Where would you start for this graph? -3. And your slope is -1/4. So I'd go down 1 and over 4 to the right, so that whenever I graph in the line, it's going in a downward direction. Now, it's going to cross right here. What is the location of that crossing place? -4, -2 is where it crosses. Are there any questions about that? Again, the special cases are exactly the same. Make sure that you know what a graph, when they're parallel, is. That will happen on the exam. All right, I'll wait a second.
Can't wait to get home and kill some aliens.
You good? All right, so the next one is not done by graphing. You could do it by graphing if I actually provided you a big enough graph to take the answer.
No, that would suck.
But that would suck. What we want to do is graph this or solve this by elimination. Elimination has several steps. We've known them well. The first step is to switch the numbers in front of the x's. So I got to switch the numbers in front of the x. So what number would I put on the top equation? a negative 15. On the bottom equation, I would put positive 5. The second step is to multiply. That means to distribute it out to the entire equation. Negative 15 times 5 is negative 75x. Negative 15 times y is negative 15y minus 15y. Negative 15 times 20 is negative 300.
Okay, yeah, I do mine so different.
There is other ways to do it. This is just the way that it'll work every time.
Okay.
Okay? 5 times negative 15, again, is negative 75x. That's what we wanted to happen. 5 times 10 is negative 50y. And 5 times 10 is a positive 50. Anybody tell me what the next step for elimination was? To subtract the equations. Very good. So I'm going to subtract. When I subtract, make sure that we're paying attention to signs. Negative 75 minus negative 75, what happens? So they cancel. You do add it. Negative 75 plus 75 is nothing. It cancels. Negative 15 minus, don't forget the minus, a negative 50 is a positive 35y, is equal to negative 300 minus 50, negative 350. After we do the subtraction, the next step is to solve. So how do I solve that? Simply divide, right? So therefore, y is equal to a negative 10. Now the problem is that's only half of my answer. The rest of my answer is going to have to be found by doing what? Yep, and that's the fifth step, is to plug back in. So when I plug it in, negative 10, which equation do you want to put it into, the top or the bottom one?
The top.
All right, the top one is the easier one, so we'll go ahead and do that. 5x plus, what is y?
Negative 10.
Negative 10 is equal to 20. So 5x minus 10 equals 20. Solve the equation, which is the last step. So the sixth step is to solve. In order to solve that, I will add 10 to both sides, giving me 5x is equal to 30. And then I'll divide, and x will then equal 6. So my solution would be at x comma y, 6 comma negative 10. X comma y is how that works. Okay? So this is my final answer, 6, negative 10. You can leave it as x equals 6, y equals negative 10. That's perfectly acceptable. But that's the way that elimination works. Elimination has the same two special cases as above, except for you won't see a graph. So what you will need to know is what they look like. And whenever I cancel everything, that means the x's, the y's, and the numbers all got canceled out. That is an example of infinite solutions. So your equations would be identical to each other. So if you cancel everything, x, y's, and numbers, that's infinite solutions. If you cancel most things, which are the x's and the y's, but not the numbers are still there, you will be left with something like 0 is equal to 12 or something like that. If this is what you're left with, 0 equals 12, that would be an example of no solutions. Okay? This would be equals 0 equals 0. That's infinite solutions. So are there any questions about the two special cases? If everything cancels, it's infinite solutions because the equations are the same. If only the x's and y's cancel, leaving you numbers there, then it's going to be no solution. Yeah? Sure.
No.
Are there any questions about the elimination process as well as the special case answers for the elimination process?
Are we doing all these today then?
We will not get through all these today. We'll get through most of them. A problem that a lot of people have is word problems. A word problem is very difficult because you have to write your own equation. So what we want to do is look at the two cases involved in the word problems. So if I look at the first one, on the first day of ticket sales, the school sold 3 senior citizen tickets, and 13 child tickets for a total of $152. Did somebody write me an equation to represent that?
I got you. Okay. 3S
S for senior,
plus 13C
C for child,
equals 152.
is equal to $152. 3 senior tickets and 13 child tickets gave you $152.
Okay, the next one.
The next one,
5S
now we are selling 5 senior citizen tickets
plus 11 child tickets
and 11 child tickets
equals $136.
equals $136.
And my calculator
So these are two equations. So your steps for doing this is the first thing you want to do is write your equations. The second thing you want to do is solve using elimination. When I solve using elimination, what I mean is doing it like we just did, like above. Your special cases are just like above as well, because it really is an elimination problem. So it's exactly the same. It's just in some sort of context. The rest of this process is going to be following those same steps. The first step was to switch the numbers in front of the x. So what number goes in front of the top? The 5. What number goes in front of the bottom? The 3. The second step was to multiply or distribute. 5 times 3 is 15s plus 75, right? 65, you're right. I thought it was 75. 65c is equal to 5 times 152. 760, just that it? 760? Then we do the same thing. 3 times 5 is 15s. 33c. 408. The next step of elimination was to do the subtraction. When I subtract them, the s's do cancel. 65 minus 33 is 32c is equal to 760 minus 408, 352. Solve that by dividing.
Going too fast.
C is equal to 11. All right, I'll slow down a little bit. So again, what I did there is I switched the numbers in front of the s. I multiplied through the entire equation. Once I got my new equations, which are in black down here, I subtracted the equations. 15s will cancel. 65 minus the 33 got me the 32c below. 760 minus the 408 got me the 352 below. And then I solved the equation by dividing. C was equal to 11. Do I just need the price of a child ticket? I also need a senior ticket. How would I figure out the senior ticket? Okay, plug it in. Do you want to do the top or the bottom equation?
The top one.
All right, so C will go in for C into the top equation.
3 times 11.
Wait a second. 3 times
3 times
S plus 13 times 11 is equal to 152. When I solve an equation like this, I want to simplify the numbers. 13 times the 11 is what?
143.
Plus 143 is equal to 152. Subtract the 143 from both sides. 3s is equal to 9. So divide it.
And S equals 3.
S is equal to 3. So a senior ticket is $3 and a child ticket is $11. That seems a little bit ridiculous to me, that a child costs so much more than a senior. I can't wait to be old. What can you do?
Yeah, life sucks.
I know. Are there any questions on how to do an elimination word problem? Those will be on your exam, I guarantee that 100%. Does anybody still need this up here?
Yes.
Okay, I'll take a minute. You done, Micah? Number 2 says solve using elimination, like above. Okay. Micah, Miss Jessie has some notes for you if you need.
Shut this door. Where did Jackson go? I'm gonna punch him in the face.
Let's go to number 9. Number 9 is very similar to solving a linear equation and graphing it problem. There's a difference here. What is the difference?
It's negative and it has a less than.
It has a less than sign as the main difference. It is negative, the slope. But I'm going to do it exactly like above. The only difference here is I need to worry about shading and type of line. So these two symbols will give me a what type of line? A dotted line. These two symbols will get me a solid line. The less than or the less than or equal to will shade above or below? Below. And the greater or the greater than or equal to sign will shade above. There are 2 special cases to worry about, which are if it is x is greater than a number, right? Remember that was a straight up and down line. Which direction would you shade if your line is going straight up and down and it was greater?
To the right.
That would be to the right. The other one would be x is less than or equal to something. That is again a straight up and down line, but this time I would shade to the left. These are always asked of me, those 2 special cases. What happens if the line goes straight up and down? That question's asked a lot, so make sure you write that down. So we're going to go ahead and graph this exactly the same. What is my y-intercept? My b is -3. What is the slope? -5/2. So I can't go down 5/2, so which way am I going to have to go?
Up to the left.
To the left 2. A negative sloping line, remember, goes that direction. We can't go up 5 anymore, so this is going to be my last dot. What type of line is this one going to have? A dotted line, because it doesn't have a line underneath. So I draw my dotted line in. And would I be shading above or below this line? How do you know it's below?
The left then.
It's not the negative sign, it's... Okay, I understand what you're saying. The less than sign says to shade below it. Below it is the smaller y values. So -3 is here, -4, -5, and 6 are on the sort of left side of that. So that's the side that you would shade in. Are there any questions about that? Number 10 is just like number 9 with one exception. What is the exception for number 10? What is the difference there? I'm sorry, Micah. Miss Jessie has the special cases and the shading if you need it. Oh, sorry. You were out of the room. Get over it. So anyway, this one right here. First thing I need to do is what?
Move the x to the other side.
Yeah, move the x to the other side. What I am really doing is solving for y, but that is a step involved with solving for y, is move the x to the other side. So I'm going to solve it by subtracting x. -y is greater than or equal to -x plus 1. What would the second step of solving for y be? Divide by what?
The -1.
Divide everything by -1. That'll leave me y is less than. Why is it y is less than? Very good. Make sure that you flip the sign if you divide by a negative. That's really the only type of special case that happens here. If you divide by the negative, you have to flip the sign. So just make sure that you're paying attention to that. Does everybody understand why it became a less than sign from a greater than sign?
No.
I divided by a -1, and that requires me to change the sign. So I flipped it around. Now I need to graph it like I normally graph it. Where would the y-intercept be? -1. The slope is what over what? 1 over 1, so I would say up 1 over 1. Is this going to be a solid or a dotted line? How do you know it's solid? Since it has a solid line underneath the symbol, that is telling you that it is a solid line. What direction does the sign face now? Now it's a less than sign. So which side would I shade, above or below?
You're going to shade below.
I am going to shade below because it is a less than sign. Now, be careful how you think about it. A lot of people still think of it as left and right, but it is not left and right because that looks to me like the right side of the line, even though it says less than. So don't think of it as left and right, but think of it more as above and below. You could look at the y-intercept of -1, less than that. Y values that are less than that are -2, -3, -4, so that side should be shaded in. Are there any questions anywhere on that? Nope. All right, we're going to stop there for today at number 10. You guys did a really good job. We'll pick up on number 11 tomorrow.
Thank you. Awesome.